This video is about Gaussian Splatting. We will use CallMap, link in the description, Blender, I'm on 5.0, and any software for computing Gaussian Splatting. This can be pulse shot, which in most cases will be free for you, or for example, Lichtfeld. So I have an old video that I want to turn into Gaussian Splatting. The problem is that the video quality is so bad that the camera motion cannot be tracked automatically in any application. So I tracked it manually in 3D in a special application and exported it to Blender. I want to use this camera motion to generate Gaussian Splatting. The trick is to replace the motion and make CallMap think that it calculated this camera motion itself. Start by converting the video into an image sequence in any common format and save it into a folder called images, like this. If the video contains distracting objects that we want to remove, create a separate mask sequence where white is everything we need and black is everything that gets in the way. Here I made a mask for the timestamp in the corner of the screen, but I forgot to mask the passing car, and it didn't affect the result. The masks should be in PNG format. For example, if your images are called image001.jpg, the mask must be called image001.png. Save the masks into a folder called masks, like this. Create a folder where all data will be stored and processed. I'll call it CallMap3. Move images and masks folders into it. Go to Blender. First of all, make sure that the exact camera you want to use for the calculation is selected. Make sure its animation is baked. If the camera uses transform cache in its constraints, for example when importing animation from Alembic, create a duplicate of the camera. Remove transform cache, add copy transforms, and set your original camera as the target. Then go to Object, Animation, Bake Action, enable Visual Keying, Clear Constraints, and Clear Parents, and press OK. Make the camera active. Remember that just selecting the camera is not enough, you also need to click the green camera icon in the object list. Then go to Output and make sure that the resolution matches your image dimensions. Also make sure aspect X and Y are set to 1, otherwise you may get errors. Switch to the Scripting tab and add the specially written script. The link to the script will be in the description, but the full text is on the screen just in case. At the top, there are 4 variables you need to configure. The first 2 are self-explanatory. The third is the name of the sequence of images you are using. The hash symbols represent digits that the script will replace with frame numbers. Make sure the number of hashes matches the number of digits in your file names. You don't need to specify the image path here, only the name. The third variable is the folder where the script will save auxiliary coordinate files. Create this folder manually. It's better if it's outside the CallMap folder. For example, I'll call it from Blender. Enter its path into the variable and run the script. In the From Blender folder, there will be created 3 text files like this. Open another window with the folder where your CallMap program is located. Go into the bin subfolder, click the address bar, type cmd and press enter. Now we need to execute the commands from this text file one by one. I'll provide the link in the description, but the full text is also on the screen. Replace your address with path to the folder with images and masks, which I have called CallMap3. Now let's execute the commands in order. You can paste them all at once, but I recommend doing them one by one so you can see any errors. All functions here are mandatory if you want everything to work. I'm not entirely sure about the last one, but it takes almost no time anyway. Feature extractor finds high contrast areas in the images, so they can be tracked later. If you have masks, copy and paste the entire command. If not, first select and run the first 3 lines, press enter, then select and run the last 2 lines. Exhaustive measure matches the detected features from image to image. mkdir creates the sparse folder, which is required for the process. Point triangulator computes the positions of points in 3D space. This is where it uses the camera coordinates we have provided. mkdir again creates another folder. Image undistorter removes camera distortion. Even if your camera already has no distortion, this step is mandatory. Patch match stereo is the longest step. The program tries to create a dense point cloud by matching whole patches between images. It will go through all images from start to end twice. You can scroll the console up to see what image it's currently processing. This can take up to an hour. The next commands stereo fusion, Poisson measure, and Delaunay measure compute geometry from the dense point cloud. I don't really know why they are needed here, but they run fairly quickly. If everything finishes without errors, then the entire set of folders and files inside the callmap directory is your result. This is the reconstructed scene structure, but not Gaussian splatting yet. You can load it for further training. I'll be using post-shot. Create a new project, drag the dense folder into it. It already contains a copy of the images folder. Then open the image masks tab and drag the masks folder there, if you have one. Select Use All Images and make sure Camera Poses is set to Import. I set limit image size to the width of our images in pixels. Click Import and the program will start training automatically. For some reason it creates two RDNC fields for me. The first one is empty, so I delete it. Due to callmap's coordinate system, your scene will be rotated downward. You can fix this by selecting the RDNC field, going to the Edit tab and entering 90 degrees in the X rotation field. But this is optional. If you switch the camera to the image set, you can play your video from the original camera. Training in this program is fairly fast. What do you do with the result is up to you. For example, I can do this. Have fun!